Testing, testing. Okay, Math 0092. We're going to continue in section 11.6, which introduces us to solving application story problems. Now on page 680, we have some keywords, phrases, and different concepts presented to us. Keywords for addition would be add, added to, sum, total, plus, more than, increased by. Keywords for subtraction, subtract, subtracted from, difference, minus, less than, decreased by, take away. Keywords for multiplication, multiply, multiplied by, product, times, of. And division, keywords that represent division, divide, divided by, quotient, and per. So take a look at those charted words and key phrases. We use those words and key phrases in story problems. So that's where we get our hints or tips as to what operation or operations we might need to use in a particular solution. So we begin by translating a phrase to a mathematical model. So twice a number. Well, twice a number would mean 2 times a number. We could write that as 2y or 2n. You can choose your variable. Twice a number would be 2 times that number. We're asked to translate 7 less than some number. Now, this is the one that probably we make the most mistakes on. 7 less than. Less than indicates subtraction. So we have some number and we want 7 less. So our English language kind of words it backwards, if you will. We're subtracting 7 from some number. So some number minus 7. And just study that so you see that you recognize how that works. 18 more than some number. Well, that's pretty straightforward. 18 more than means addition. Some number, well, t, 18 plus y. You get to choose your variable, 18 plus n, or even some number plus 18 would be an equivalent expression. A number divided by 5. Divided means division, so I have some number divided by 5, some number divided by 5, some number, and then use your forward slash for division. So several ways we can make use of our symbolism, but you get to choose the variable unless you're told at my math lab to use a particular variable. Then on page 683, we have our story problem. 683. Lily knitted a scarf with orange and red yarn, starting with an orange section, then a medium red section, and finally a dark red section. So here's our orange section, our medium red, and that's the dark orange section. The medium red section is 1/2 the length of the orange section. So if the orange section is X, the medium red would be 1/2 of the orange section. The dark red section is 1/4 the length of the orange section. So the dark red section is 1/4 the orange, which is our X section. Now we don't know the length yet, but we know that ratio. The scarf is 7 feet long. Find the length of each section of the scarf. So our total scarf is 7 feet long. So let's see. If we add the sections from our scarf, this is my orange section, and we'll call it X. We don't know its length. Here's a medium red section, and it was 1/2 the length of our orange section, and the dark red section was 1/4 the length of the orange section. And the total length is 7 feet. So if I add my sections, the orange section plus the medium red section plus the length of the dark red section, it should equal our total of 7 feet. So now I want to collect like terms, x, x, and x, but there's fractions involved. So let's get rid of fractions. We have a 2 and a 4. 2 is 1 times 2, and 4 is 2 times 2. I have a factor of 2 from the first column. I can check off there, but I need another factor of 2. And of course, my least common multiple is 4. So let's get rid of fractions in this story problem. We're going to multiply both sides of the equation by our least common multiple of all denominators. 4 times x would be 4x. Pick up your sign. 4 times 1/2 x. 1/2 of 4 is 2 times x. Pick up your sign. And 4 times 1/4 x. 1/4 of 4 is 1 times x would be x. 7 times 4 is 28. Now it looks like I can collect like terms. I've gotten rid of fractions. 2x plus 4x plus 1x would be 7x equals 28. I'm solving for x, not 7 times x. There's your indicator. We're going to use our multiplication principle and multiply by this reciprocal. The reciprocal of 7 is 1/7. Flip it and keep the sign. But if I multiply this side of the equation by some value, I need to multiply by the same value on the other side of the equation. A number times its reciprocal goes to 1. 1 times x is x equals. Getting close to solving. I have 28 over 7. And x equals, 7 goes into 28 4 times. So the x length is 4 feet. 1/2 of x would be 1/2 of 4 equals 2 feet. And 1/4 of x would be 1/4 of 4 equals 1 foot. So our orange section is 4 feet. Our medium red section is 2 feet. And the dark red section is 1 foot for a total of 7 feet. Our delivery truck on page 684. An appliance business needs to rent a delivery truck for 6 days while one of its trucks is being repaired. The cost of renting a 16-foot truck is $29.95 per day plus 29 cents per mile. If $550 is budgeted for the rental, how many miles can the truck be driven without exceeding our budget? So our cost to rent is $29.95 per day, plus our use of 29 cents per mile. Now our budget is $550, and we're going to need to rent this truck for 6 days, but we don't know the number of miles that we can drive yet to stay within our budget. So I have 550. 29.95 times 6 on your calculator is 179.70 plus 0.29 are unknown miles. So we're trying to solve for miles in this case, so we're looking for m equals. I'm going to isolate that by using my addition principle, adding the opposite of 179.70 to both sides. Adding opposites goes to 0, leaving 0.29 miles. And 550 subtract 179.70 on your calculator is 370.30. I'm solving for m, not 0.29 times m, so there's your tip. We're going to multiplication principle, multiply by the reciprocal. So I'm going to multiply by 1 over 0.29 and keep the sign. So I'll multiply by 1 over 0.29 on this side of the equation. Now I have 370.30 divided by 0.29 is equal to a number times its reciprocal goes to 1. 1 times m is m. So we're getting close. We just need to resolve this. $370.3 divided by 0.29 is 1,276.90. So 1,276.90 equals miles. And then we might be asked to round to a nearest mile. So that'd be 1,277 miles. So the truck can be driven 1,277 miles for the budgeted amount of $550. This is on page 685. Perimeter. The perimeter of a lacrosse field is 340 yards. The length is 50 yards more than the width. Find the dimensions of the field. So we'll sketch our diagram. If this is the width, the length is 50 yards more. Now we remember that perimeter is equal to 2 times length plus 2 times width. We're going to add the length all the way around so we can put a fence around our garden to keep the rabbits out. So we have 2 lengths and we have 2 widths. Now they told us that our perimeter is equal to 340 yards. So 2 times the length plus 2 times the width is equal to 340 yards. 2 times our length would be 2 times W plus 50, substituting, plus 2 times our width, which is W, equals 340. I'm going to use a distributive law to distribute. 2 times W would be 2W. Pick up my sign, and 2 times 50 is 100, plus 2W. Looks like I can collect like terms, W and W, so I have 4W plus 100 equals 340. I'm trying to isolate my W term so I can solve for W equals. So I'm going to add a negative 100. with the addition principle. To both sides, I'm adding opposites, which goes to 0, so I have 4w equals 340 subtract 100 is 240. Getting close. I've isolated my w term, but now I need to solve for w. This is 4 times w, so we'll use our multiplication principle to unwrap. We'll multiply by the reciprocal. The reciprocal of 4 is 1/4. Flip it and keep the sign. So I'll multiply this side by 1/4. Multiplying reciprocals goes to 1. 1 times w is w equals, and 4 goes into 240 60 times. So the width is 60 yards, and the length is equal to w plus 50. So 60 plus 50 would be 110 yards. So the length of our field is 110 yards, and the width of our field is 60 yards. Next, we're going to look at a triangle and remember some of our facts regarding triangles. The second angle of a triangle is twice as large as the first. The measure of the third angle is 20 degrees greater than the first. How large are the angles? So we're looking at relationships on a triangle with respect to the first angle. So if my first angle is x degrees, it says the second angle of the triangle is twice as large as the first. So that'd be 2 times x. Twice as large as the first angle would be 2 times x. The measure of the third angle is 20 degrees greater than that of the first angle. So if I have my first angle plus 20 degrees, that would be x plus 20 degrees. So now I have a relationship based off of my first angle for the degree measurement of all the interior angles of this triangle. And then we remember that the sum of the interior angles of a triangle is equal to 180 degrees. Now you'd have to remember that or look it up. The sum of the interior angles is 180 degrees. So it looks like I can first collect like terms. I have x plus 2x plus x would be 4x plus 20 equals 180. I'm trying to isolate my variable terms, so I'll use the addition principle and subtract 20 from both sides. Get 4x equals 160. Now 4 times x, my x term is isolated, but I need to unwrap it. It's tied up in multiplication. So I'll use my multiplication principle. 1/4 times 4x equals 160 times, if I multiply by the reciprocal here, I'll have to multiply by the same value on this side of the equation. A number times its reciprocal goes to 1, leaving x equals 160 divided by 4. X equals 4 goes into 160. 40. So our first angle is 40 degrees. Our second angle is 2x. 2 times 40 is 80 degrees. And our third angle is x plus 20 degrees. So that'd be 40 plus 20 degrees is 60 degrees. And sure enough, that adds up to 180 degrees. So we determined the interior angles of a given triangle. This is example 11 on page 687. It says the average top speed of the 3 fastest roller coasters in the United States is 116 miles per hour. That's the average of the top 3. The 3rd fastest roller coaster reaches a top speed of 28 miles per hour, less than that of the fastest. So if I have my fastest, 2nd fastest, and my 3rd fastest. The 3rd fastest roller coaster reaches a top speed that is 28 miles per hour less than that of the fastest. So if my fastest roller coaster is X miles per hour, the 3rd fastest roller coaster is 28 miles per hour less than the fastest. So that'd be X minus 28. The 2nd fastest roller coaster has a top speed of 120 miles per hour. So that's constant, 120 miles per hour. And we're supposed to find what is the top speed of the fastest steel roller coaster. Well, we know that their average is 116 miles per hour. So remembering what average means, it means we add our data values and divide by the count. And there's 3 of them. So that would be equal to our average. And now we want to solve for x equals. Well, I see fractions, so let's get rid of those fractions. Our only denominator is 3, so the least common multiple is 3. Let's multiply both sides, all terms, by 3. Now, this is all divided by 3, so 3 goes into 3 once, leaving x plus 120 plus x minus 28 equals 3 times 116 is 348. So I can collect like terms. X and x would be 2x, and my constants, 120 subtract 28 would be a positive 92 equals 348. Now I'm trying to isolate that x term. I'll have to move this term to the other side using the addition principle. I'll add the opposite. 2x equals 348 subtract 92 is 256. Now I'm getting close. I have my x term isolated. It's 2 times x, so that's your hint. Use the multiplication principle to multiply by the reciprocal. The reciprocal of 2 is 1/2. Flip it and keep the sign. But if I multiply this side by 1/2, because of some strategy, I'll have to multiply the other side by 1/2. A number times its reciprocal goes to 1, leaving x, and I have 256 divided by 2. And 256 divided by 2 is 128. Now we are asked to find the speed of the fastest roller coaster. So the fastest roller coaster speed is 128 miles per hour. The 2nd roller coaster is 120 miles per hour. It was a constant given to us already. But the 3rd fastest is x minus 28 at 100 miles per hour. This is on page 688. Simple interest. An investment is made at 3% simple interest for 1 year. It grows to $746.75. How much was originally invested? Well, we want to think about investment for 1 year. We have our principal that we invested plus the interest that we might earn. And that'd be equal to the amount at the end of the year. So the principal, we don't know how much was invested yet, but interest would be whatever we invested times 3% in this case. And that's going to be equal to the amount that we earn at the end of the year. So we have our principal amount plus, this is 3%. Remember, we can change that to 0.03 times P. Get rid of your percent sign and move the decimal point 2 places to the left, is equal to the amount at the end of the year. They told us that at the end of the year, our account had grown from the principal plus the interest to $746.75. So now we just need to solve for P. Now, careful, this is a very common mistake. We're adding like terms, but this is actually 1 times P. So adding, I have 1P plus 0.03P, which would be 1.03 times P. So I collected like terms. 1P plus 0.03P would be 1.03P. Well, I've isolated my variable term, but it's tied up in multiplication, 1.03 times P. So we need to unwrap that with the multiplication principle. We'll multiply by the reciprocal. The reciprocal of 1.03 is 1 over 1.03, and we keep the sign. But again, if I multiply one side of the equation by some value, I have to multiply the other side by the same value. Now a number times its reciprocal goes to 1, leaving 1 times P is P. And I clean this up a little bit, divided by 1.03. So on my calculator, I have 746.75 divided by 1.03 is equal to 725. And we were talking about the principal amount, so our principal is $725. So the original investment was $725, which at the end of 1 year, when I invested at a rate of 3%, I earned $746.75. Now that gives you a wide range of sample application problems that you will be able to study and look at on homework and tests, of course. But at the end of the chapter, at the end of this section particularly, 11.6, there's several examples. And remember that there is the 11.6 section video for you to get more experience with application problems as well. So return to D2L Brightspace for all details regarding homework, assignments, tests, and their due dates. And thank you very much.